All right, so warm up. Determine if the triangles are congruent using the rules we already know. If so, write a congruent statement. So PQR. Well, we go through and mark what we can mark. So we mark these two angles congruent because they are vertical. Okay, so we mark the angles congruent. Now we label. We have A here, sorry, S. We have a side here, we have an angle here, we have a side here. See if it matches. 1, 1, angle, 2, 2. So we have SAS. So we follow order, PRQ. Going down Highway 1, Highway 2. So we start at T, down Highway 1, to R to S. And we're going to add by SAS. That's the rule we're using. Now, number 2, there's some work to be done. The previous assessment, you had problems like this, and some people did not seem to know what to do. You have to do something. Yes, you're given one mark, one side mark. Obviously, that's not going to be enough to prove these congruent. But you were given information. It says angle M is congruent to angle P. So you go in and you mark angle M and angle P are congruent. Now, MON, where is that? Well, MON is right here. It is congruent to POQ. Where is that? That's right here. So we mark those congruent. You actually have to do some work. Anything that you're told is congruent, you have to go in and mark it congruent with hash marks and arc marks. Now that we have everything marked, we go through and label what we have. Do we have a rule? Yes, we do. Now, how do we do it? MON. Angle 1, angle 2. So angle 1 is P, angle 2 is O, and then Q. And by what rule? ASA. All right. We have nothing on the picture. But we know anytime we see one of those middle lines, we can always immediately mark it. So we mark SU equal to itself, as we've been doing for a while. Now it tells us angle T, right here, is congruent to V right here, so we mark it. We also know that TU, with these 2 marks, is congruent to VU. Okay? Now, what do we have? We have an angle, we have a side, and we have a side. Let's check our directions. If so, write a congruent statement. Are they congruent? Well, we don't have enough information. We have ASS. We cannot use that rule. So that's a no, or an NP, not provable. And since we don't have a right angle, we can't use HL. Number 4, AB is congruent, and there's nothing marked. Also, I want you to look carefully here. Right here, those are not vertical angles. All right? This is not an X. So those are not vertical angles. Very common mistake is to mark those vertical. They're not. So don't mark anything, but do not do that. That is a very common mistake to mark those vertical. They're not vertical. They don't form an X. So we don't do that. What can we mark? Let's see. AB, which is right here, is congruent to DE. So we put a hash mark there. BC, different number of hash marks, is congruent to EC. Angle D, right here, are right angles. So these are all marked there. Those are right angles. They're also congruent to each other, but they are right angles. Now, given that we have right angle, here's our hypotenuse. We have a leg. We can say now, a little more space here. And you can choose the order. You can start wherever you want, A, B, C, C, A, B, whatever. I'm going to say triangle BAC. Okay? So I'm going down highway 1 to the right angle is congruent to triangle. Well, if I start at B and went down highway 1, that means I'm going to start at E and go down highway 1 to D. And then end up at C. And then by what rule? By HL. So the key to success with proofs that we're going into now is labeling everything you're given and what you know. So we've been labeling everything we know, lines in the middle, vertical angles, but also if they give us statements like this, we have to go through and physically mark things. All right. Naming sides and angles. Name the purple segment. Well, that's kind of up to discretion because some people might call this purple. I don't know. So let's just go with it. I would say either BR, and if you want to go with light purple, I would accept RT. But the key thing is, don't forget the segment signals. Simple. All right, well, apparently this isn't in the packet, so never mind. Here we go, proofs. So, we're going to use something called a two-column proof to prove triangles congruent. So let's put our rules on here real quick. SAS, ASA, AAS, side, 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 and HL. Just as a reminder, those are the 5 rules we have. SAS, ASA, AAS, SSS, and HL. Now, tips. Draw the picture and mark the drawing, which we just practiced. You have to mark everything. People who don't mark things don't do well. I'll just tell you that right now. If you don't mark things, you will not do it well. Write down any given information. This will make sense once we do it. Can you use the given? Okay, we'll get to that in a little while. Do they share any sides or have any vertical angles? That's what we've been talking about. If it's the same side, mark it. Prove the triangle is congruent using one of our rules we've learned. So that's what we're going to be doing. So, write a two-column proof. Here's an example right here, example 1. So we looked at our drawing. We have nothing marked. But we know we can go ahead and mark. The word will cooperate. We know we can mark angles 3 and 4 congruent. That and that. We know that. Now, what's given to us? X and P are congruent. So we can mark angle 1 and angle 6 with 2 arc marks. And then we're given MP, which is right here, is congruent to XM, which is right here. Now, this is nothing new, right? So far, there's nothing new from what we've done. We go and say, hey, this is an angle, that's a side, and that's an angle. What we've been doing up to this point is coming up with this statement. Well, we're going past that. We're saying, I'm telling you I know they're congruent. You got to show me why they're congruent. Okay? So, we're going to have what's called a two-column proof. Now, what we do right at the bat is we say what's given to us. Angle X is congruent to angle P. And we say MP is congruent to XM. And we say given. Because that's what was given to us. We know that. Now, we have to state what we were given, but that we know. We know those two angles are vertical angles. We know they're equal to each other. Now, in this case, since there are numbers, we can just say angle 3 is congruent to angle 4. If the numbers were not there, and they won't always be there, we'd actually have to name the angles with 3 letters. So let's see how we name angle 3. We'd have to call it XMO. Or we could call it OMX. That doesn't matter. The order doesn't matter, except in the second one. We have to go in the same order. So let's say we say XMO. Now I'm going to put an OR here because there's choices on this one. This is just instruction. Angle XMO is congruent to. I wrote that underneath 3 because it's the same thing as 3. Now be careful. Notice with XMO, I started at the arcs, the 2 arc marks, which means I have to start not at LMP, I have to do PML. I have to go the same order. You will lose partial points if you say XMO and LMP because they don't line up. X matches P. And if you look at this, the little trick we taught you, XML, PMO. So if I'm saying XMO, that doesn't make sense. That's a typo. This should be XMO. XMO. Yeah, this should be the O here. And that should be PML. Those got reversed. So fix those, please. That doesn't make sense. Because XML is not a triangle. Okay. So XML, I'm going to make this PML. XMO, PML. So if I say XMO, it's got to match the same letters up here. So you can kind of cheat that way. Angle PML. Those match up. If I say LMP, you will lose partial points. Yes, it's the same angle. It's still where the M is, but you have to go in the same order. All right? Now, what's our proof for that? What have we been saying? Why do we know they're equal? Definition of vertical angles. And I'll let you abbreviate. Definition of vertical angles. That's how we knew we could mark them, because we know vertical angles are equal. And now, we're done. We can say triangle XMO is congruent to triangle PML. Now what's our reasoning? A, S, A. And that's it. And I forgot to mention, I added statements and reasons to the top there. That is always the label for the columns. So moving on. Number 2. We'll go a little quicker through this. A little bit smaller. All right. So, right off the bat, we know this. That side is equal to itself. Then we also know SPT. So we follow SPT, which is right here. That angle right there is congruent to OPT, which is this angle right there. So these 2 angles are congruent. That's given to us. SP is also given to us, congruent to PO. So what do we have? SAS, SAS, provable. All right? So, statement, reasons. So first off, start with the given. So we just repeat what we were given, literally. SPT is congruent to angle OPT. Then line segment SP is congruent to line segment PO. And then both of those are given to us. Now, what did we mark? We marked that TP, this is new, we've been saying it, is congruent to itself. And this is called the reflexive property. Now think about what reflexive. If you look in the mirror, you see a reflection of yourself. So the reflexive property says something is equal to itself. Very simple. And then we've done it. We can say that triangle SPT is congruent to triangle OPT. And what reason? SAS. That's it. Remember, hit pause if you need to. Okay, example 3. Let's mark what we know. Equal to itself, reflexive property. C is the midpoint of BD. If this is the midpoint of this entire segment, that means that this and this are equal. It splits it up into 2 equal pieces. And then BCF, which is right here, is congruent to DCF, which is right there. So we have side, angle, side, side, angle, side. We're good to go. So these actually go pretty fast. Statement, reason. All right? So, again, repeat. C is midpoint of BD. Angle BCF is congruent to angle DCF, and both of those were given to us. We added one piece of information. We said that CF was congruent to itself. And that's a reflexive property. You can abbreviate that if you want. Reflexive property. And then we got it. Triangle BCF is congruent to triangle DCF. And what rule? We said SAS. And last one for this. Well, we'll get to it. Name the vertical angle step. Okay? Well, we know that this is congruent to this. So, we can say that angle 3 is congruent to angle 4. But if there were no numbers, we would have to say XMO is congruent to angle, now this one we don't know, but before it was PML, so we're going to repeat what we did in the first example. PML. Notice how the vertex is in the middle. C is the midpoint of BD. State what you know. Well, because of the midpoint, we know this is equal to that. And then the reflexive step, that is equal to itself. Okay, last one we're doing here. Statement, reason. I'm going to mark vertical angles. Notice there's no numbers, so we're going to have to use letters. It also tells us X and P are congruent. That's going to be very important for naming that angle at M. And M is the midpoint of XP, which means this is equal to this. So we have ASA. ASA. And we're ready to go. Okay, so we give our reason, our statements first, given angle X congruent to angle P. M is the midpoint of XP. Those are both given. That's all we have to write. Now we said XMO, angle XMO, is congruent to, now careful here, I started at the angle with the 2 marks, so I have to start at P, and then come up to M, because it has to stay in the middle, and then L. Now I say, definition of vertical angles. I can abbreviate that. And I'm done. Except for saying the last one. Triangle XOM is congruent to triangle PML by ASA. And that's it.